Alright guys, so we were talking about the Ummagawd 2Fiddy frame. So I've had this for quite a while, and the frame here is a earlier version. It's close to the final, but not the actual final version. I'll talk about some of the differences. Not too different, so it shouldn't make much difference in terms of the flight characteristics, which I'll talk about at the end. But first I'll talk about the frame, and then I'll talk about how I built it. Obviously there's a very wide variety of ways you can build it, so I'll talk about all those differences later in the video. But first talk about the frame, how I built it, and then how it flies. So the frame itself here, obviously 5-inch frame, ultralight. Now there's going to be some debate as to whether or not you want to go for the lightest possible frame that can hold a motor that swings a 5-inch prop, because you can do that and you'll get a totally different experience if you want to go for the lightest frame. Tommy did not go for the lightest frame. He wanted to kind of have a balance of a lighter frame while maximizing the durability of the frame and flight characteristics. So you kind of have to balance all those things. If you just like go for a frame that's purely just as light as possible, then what you're really doing is you're basically finding the lightest frame, the lightest electronics, and maximizing your flight time. You can trade off that weight to get more battery to get under that 250 gram goal. So that's kind of the goal of this frame, is basically find the best set of characteristics of frame weight, frame durability, and flight time, and try and squeeze that into that under 250 gram weight limit. Now obviously, there's a lot of you guys out there that don't care about that, and I get it. This video is not going to be for you. Probably should stop watching right now, because this is basically what this frame is all about, and the goal of this design is to find the best characteristics under that 250 gram limit. So if you do care about that, then continue watching. But if you don't, then you're probably not going to care about this frame. Just get a 5-inch and a regular 5-inch, and that weighs 700 grams, and fly it like you normally do. This video is probably not relevant for you. Now that being said, Tommy does have actually a few videos. I'll link them down in the description as to what his specific design goals were. So if you want to get more details into that, I'm obviously not going to regurgitate all of that here. I just wanted to give you sort of a summary. But if you want to watch all those details on why he made the choices he made for this design, I'll link those videos down in the description. You can watch those videos and get a more detailed understanding of what's going on with this particular frame. So a few things that are different on the one I have here. The arms are a little bit different. So the hole pattern here for the motor was originally here designed for his particular motor, which I'll talk about here in a second. It's a special 2004 motor that was basically meant for this frame only. And so it has the two screw holes that mount the motor in line with the arm like this. But while that works great for this motor, if you want to use a standard motor with 4 holes, then the motor wire is going to come out at a funny angle. So he changed the design here so that it can accommodate either his standard motor here or his motor, or a more standard motor that has the regular 4 holes. I kind of wish that more manufacturers will adopt this design with just the 2 screw holes, because you don't really need 4 unless you're looking for massive amounts of durability. And since we're looking for less weight, you want to have a motor with less weight. You just want the 2 holes. That's all you really need. And yeah, but if the updated design will accommodate those of you guys that don't want to use the lighter motor here. You want to use a standard motor from a different manufacturer. The updated frame will have that. Now the holes here on the end, my understanding is for a brace that should be available as, I believe it'll be available as a separate part you can buy. So if you want a little bit more stiffness in the frame, a little bit more durability, you can screw that brace into the side here. I didn't, it actually didn't build mine that way. Now the mount holes here, or the mounting, I guess, screws or nuts here for the Vista, is not in the final design. This is going to be a standard M2 hole here that you can put a screw through and then secure with a nut. But in this particular instance, I think, yeah, I just used 2 screws here. one right there and over there, and it just goes, basically it's just a threaded nut that's into the carbon fiber that holds the Vista. So you change the design, so there's just a standard M2 hole, and you can use your own screw. I don't know if this is better or if the other way is better. Obviously I didn't test both configurations, but the way you're seeing it here with these nuts already built into the frame is not going to be in the final design. It's just going to be a standard M2 hole there. Now you can see that on mine, I have the standard DJI camera for the Vista, and you can see the original design was for this camera with the 2 holes there. But if you're using like a Nebula Pro camera, or like a different camera, like maybe the micro size camera, then this doesn't work with this one you're seeing here. So he changed it slightly so there's a 3rd screw hole here for the micro size cameras, and so if you're using a Nebula Pro, the updated frame will accommodate that as well as the DJI camera. Now, as you can see here, I'm using the shorter standoffs. You can build this kind of sort of like slammed here with an all-in-one board, and it does have the shorter standoffs. These are 14mm standoffs, but if you want to build it with like a separate ESC and a separate flight controller, you can do that. I think you just have to get the version with the longer standoffs. I don't have that version, and I didn't fly it, so I know there's going to be a lot of people who are going to be commenting and asking, how does this compare to the version with the 20mm standoffs, or the version with the 4-inch arms, or the version with etc., etc. This is the only version I've ever flown. So if you're going to be asking that question, you're probably going to have to wait for an answer from somebody else, because I basically don't know. But I opted for the slammed version here, because I wanted to go for as light as possible, and went for an all-in-one board build. So I went for the lower 14mm standoffs here. It's a very nice slim profile. Obviously with the battery lower and in line with the props, as you can see here, it does affect the flight characteristics a little bit versus a battery being a little bit higher up off the CG line. But then it does limit your options in terms of what you can build with, and I'll explain what I used to build this out in terms of electronics in a little bit later. Okay, I do want to talk a little about the motor, and it does come with titanium screws for the props. Actually, I'm not sure if he's changed that or not, but the ones that originally came with this motor had like not the M2, or I guess I forget the name of what the screw is. It's like it's an M2 screw with a 1.3mm hex driver instead of the 1.5mm hex driver. So if I don't know if the motors are going to be coming with those screws or with the newer ones. I'll have to look at the website. But yeah, I swapped out for some different titanium screws here to make it lighter. These have the standard 1.5mm hex driver, and then the motor itself is very light. Has a lot of these sort of cutouts. Basically make the motor a bit lighter. You can look at the specs on the website. I didn't actually measure the weight of the motor compared to every single other 2004 motor out there. This one here is, I think, 2400 kV. Yeah, so comes in 2400 kV and 1700 kV. So this one, obviously, I flew on 4S. You can probably run this on 6S with a motor output limit to simulate a 1700 kV motor. I'll make another video later on how to do that, because I know some people are asking about that. So I'll probably just I have to get a 6S battery that is like around the same weight as this 450 milliamp hour 4S. So I'm waiting for that. I have ordered some, but yeah, the motor here is quite a bit different than a lot of the 2004 motors out there. It's a bit lighter. Obviously pretty standard in terms of the winding. Single-stranded copper wire. The motor bearing is bigger than on a lot of the other 2004 motors out there. I think they use 7mm bearings on most of the other 2004 motors out there. This one uses a bigger 8mm bearing, so the motor feels way smoother than most other 2004 motors out there that I've flown. Plus, with a bigger bearing, when you crash, it's going to hold up better over time, because it has the center part or surrounding the shaft is just going to be a little bit more solid than compared to a lot of other motors out there. So it's going to hold up better in crashes. And you probably saw his video where he threw this, crashes into walls, poles, trees, and the motors seem to hold up really well. Okay, so I'm going to talk about how I put this together. I used one of the new Flywoo, I think it's the G745 all-in-one board. I'll put a link in the description to all the parts I used in this particular build. Basically, it's I think it's like 45 amp all-in-one flight controller, ESC, and F7 board. It's one of the newest ones. It's 20 millimeter in terms of the mounting pattern. You can see where the motor wires solder to the corners right there and there. So it's a pretty easy build. This frame can take either a 20 by 20 for mounting, or you can do an all-in-one, a traditional whip style all-in-one with the basically a 25 or 26 millimeter mounting holes here, as you can see diagonally, or you can go for a 30 by 30 board with these larger M3 holes here. So it gives you this frame gives you a lot of options in terms of a build. So you can choose different parts, but obviously if you want to go for a lighter build, I would recommend going with an all-in-one board, either 20 by 20 or 25 by 25 millimeter whip style all-in-one board, just to keep the weight down. Although, that the disadvantage is if you do burn out an ESC from a hard crash or something like that, you do have to swap out that whole board, and those tend to be a bit more expensive. So the rest of the build is fairly straightforward. It's Vista DJI, so basically you just have your Vista wired up to the flight controller, and I think this particular one has a 9 or 10 volt BEC specifically for DJI. So I have that wired in there. I do have Crossfire in here that is right there under the battery strap, and I'm just using one of these like mini Crossfire antennas, and didn't really have any good way of mounting this here in the front, so I just used some dental floss, and that seems fine. Obviously in a hard crash, something like that, I probably get ripped off, but I'm okay with that. I can just reinstall it or get some new dental floss and put that back on. Shouldn't be a problem. Alright, so here's how much it weighs. This is my particular build, so with all the parts that you'll see in the description, this is what you should expect it to weigh. The weight might vary a little bit based on the updates to the frame. I don't think it's going to drastically change from this. It's around 178 grams. And then I flew mine with a 4S450, and there's a wide variety of 4S450s out there. This one here is the Beta FPV version, and this altogether is coming in around 233 grams. I did also fly it a little bit with the a Race Day Quad 650 4S, and that just got under the total weight with that was just under 250 grams. So it was like 248 grams. So if you want to have a little bit more flight time, you can up the weight a little bit. But I feel like for this setup here on 4S with this 4S battery, if you're okay with a 4.5 minute flight with a lot of power loops and stuff like that, that's what you're going to get with this particular setup right here. But if you want more flight time, you're going to you sacrifice a little bit of agility, and it just doesn't feel quite as responsive with a little bit more weight. I mean, yeah, it's only 15 more grams, but on something this light, every 5 grams or so, you can feel differences in how it flies. For the most part, if you're just a beginner, you're not going to be able to tell, but if you're a more experienced pilot, you're probably going to notice the differences in the different slight variations in weight. For me, I found this weight with this battery and this flight time combination to be my preference. So, it's going to be subjective. You may prefer the longer flight time with a little bit less agility and a little bit less responsiveness. That it's really totally up to you. Again, now I'm just focusing on trying to keep it under 250 grams. So you can go over 250 grams in the setup and go to an 850 4S and get like a 10-minute flight if you want. If you're just going to cruise around, you can certainly do that, or carry around a giant battery like a 1500 4S if you want to, and just cruise around. And the 2004 motors can carry the weight. It's just that you're basically going to be just cruising around. You can't do any like fancy tricks with a giant 1500 milliamp hour 4S battery in here that is going to put you at like 350 to 400 grams. So just keep that in mind, because it's such a trade-off, right? So if you want more flight time but less accurability, you can do that, but you're going to probably go over the 250 gram limit, of course, and that kind of defeats the purpose of what this frame is designed for. In which case, if you don't care about that, you should probably go for a totally different frame. Okay, so to end the video here, just going to talk a little bit about how I feel this flies in comparison to like a regular 5-inch that carries like a GoPro. Obviously there's no GoPro on here. You're just seeing the DJI footage, which, if you're okay with that, and a lot of people are, then, you basically gain that ability to get under 250 grams, still get nice, semi-nice 1080p, footage that you can share on Instagram and Facebook. Obviously, if you're trying to share some 4K footage on YouTube, this is not going to be your frame that you want to go for, because you're going to have to put a GoPro on here. Obviously you can do that, just that you're not going to be able to keep it under 250 grams with a GoPro on here, so just keep that in mind. But comparing it to like a 5-inch, with a GoPro, it weighs like 700 grams all up weight. You get way more power with that bigger setup than this. It's going to just, it's completely different. I don't think Tommy was going for the trying to replicate that feel, but something kind of similar in terms of the fun factor. And you do have to sort of realize when you fly it, you're going to be flying it a little bit differently, and your expectations are going to have to be a little bit different in terms of you shouldn't build this and think, oh, it's going to fly like my 700 gram 5-inch, because you can't. No matter what you do, even though you're flying it with a 5-inch prop, you can't replicate the weight, and that's the biggest difference. Is when you try and fly, a lot of like 5-inch freestyle flight has to do with like throwing the quad over like a tree or some object, and you're using the weight of the quad and the basically the inertia and the momentum to carry that through a move. And you can't really do that with this one. You have to kind of hold your throttle. You can't like cut the throttle. You basically, on a regular 5-inch, you can give it a nice big blip of throttle, cut the throttle, and then it'll maintain its momentum over a move. Whereas this one, you can't really do that. You have to kind of maintain your throttle over a move. But so certain kind of moves where you're going to basically flip it over and change direction, and then when the thrust changes, it actually basically cuts off your momentum. So certain moves aren't going to look anywhere close to the same as it did on a larger 5-inch with a GoPro. So just keep that in mind. Your expectations have to be a little bit different when it comes to this one. I think the more you fly, you're going to kind of find different ways of maybe doing different kinds of tricks. And I think that's what we'll probably see down the road with this one, is people will fly this and learn how to fly it in a different way. So you'll see different kinds of new tricks with this one that you haven't seen before, that you can't do with a regular 700 gram 5-inch. Because one of the things is, because this is so light and the motors are so responsive at this weight, you can basically have moves where you're basically falling with no throttle and nearly stop on the dime close to the ground, whereas you can't do the kind of stuff with a much heavier quad. So I think those are the kinds of new things you might going to see down the road, where maybe if you're taking more chances in certain situations where you feel like you have very little margin for error, really tight gaps, like under certain objects, for example, you might be able to pull it off with this particular quad, but something that you couldn't do with a larger 5-inch. So those are the kind of things I kind of expect down the road. We'll see. Obviously there's a lot of really talented pilots out there. They're probably going to get their hands on this, and we're going to probably see some new and different kinds of FPV tricks out of this one here that we probably haven't seen before. Anyway, I hope the video was helpful in terms of helping you decide whether or not this is for you or not. If you have any questions, let me know down in the comment section below, and I'll talk to you guys in the next video.